here we have another problem. We want to show that 1 plus tan square theta is equal to sec square theta. So the first thing we need to do here is to say that 1 plus, we have already defined tan theta to be sine theta all over cos theta. Because of the square, we include the square. We want to show that the whole of this can produce sec square theta. Alright, so let's keep going. 1 plus this all square is the same thing as sine square theta all over cos square theta. So let's look for the LCM of the denominator. The LCM here will be cos square theta. 1 goes into cos square theta is cos square theta times 1. We have here to be cos square theta plus cos square theta into cos square theta will be 1. 1 times sine square theta will be sine square theta. Alright, but we are having this expression at the numerator. Recall that cos square theta plus sine square theta equal to 1. We've proven this before. Alright, so wherever we see cos square theta plus sine square theta, we just represent it with 1. So here becomes 1 over, here we represent, or we replace here with 1 all over cos square theta. And from the definition of sec theta, 1 over cos is sec. Because of this square, it becomes sec square theta. Alright, alternatively, we could just introduce this. Recall that cos square theta plus sine square theta is equal to 1. Okay, so if we divide both sides by cos square theta, cos square theta, this over cos square theta, this over cos square theta, you see that this can cancel this and 1 will be remaining here. Plus, we know that sine over cos is tan. We've proven that. Because of the square, have tan square theta, and 1 over cos is sec. You can see that in one line we've proven it. Alright,